Okay, with this problem, we're going to practice calculating the osmolarity of a solution. And so the problem says, what is the osmolarity in milliosmoles per liter of a normal saline solution? And it's got a 0.9% concentration of sodium chloride, and we're told that the molecular weight of that sodium chloride is 58.5. And we will round our answer to the nearest whole number. Okay, so here's our strategy. So step one, we'll calculate the quantity of the substance in grams, in this case the sodium chloride that's in the solution. Then step two, we're going to use the formula below to calculate the osmolarity. So we'll plug in the appropriate values into the formula and calculate our osmolarity in milliosmoles per liter. Okay, well let's go and work this one out. Okay, this problem says, what is the osmolarity in milliosmoles per liter of normal saline solution, which has a 0.9% concentration of sodium chloride, and the sodium chloride has a molecular weight of 58.5, and we got to round our answer to the nearest whole number. All right, so first step here is we need to determine, well, how much sodium chloride is in the solution. So we know that 0.9%, we can also express that as 0.9 grams for every 100 milliliters. We could do dimensional analysis. We could set up a proportion. I'll do a proportion. Now, question is, well, proportion out of what volume? Well, milliosmoles per liter. Volume is not specified here. In milliosmoles per liter is always, well, per liter, which is 1,000 milliliters. So we'll just do it out of 1,000 milliliters, and I'll put X here for the number of grams per 1,000 milliliters. So we'll solve for X, and we end up with 9 grams. Okay, and then for the milliosmoles, we've got to use our formula for calculating milliosmoles per liter, which of course is grams per liter. So in this case, this is 9 grams, but it's 9 grams within 1 liter here. So this is 9 grams per liter, so it's 9. Then we divide it by the molecular weight, 58.5, times the number of particles. Well, sodium chloride, this is one you should have memorized. Sodium chloride dissociates into 2 particles when placed in solution. So times 2 times 1,000, and this will give us our number of milliosmoles. We're told to round it to the nearest whole number, and you should end up with 308, and that's milliosmoles in 1 liter, so per liter. And that is our answer.